Hi everyone, in this time I discuss about very most important topic. This topic is test for normality. Okay, it is very most important. Okay, please you note down. I provide this topic. Okay. Let test for normality. Okay, it is group theory. Okay, group theory question. Group theory. Okay, group theory. Okay, let H be a subgroup of a G. Then H is a normal in G if and only if and only if H belongs to capital H. Okay, always remember H belongs to capital H. Okay, and H belongs to capital H and X belongs to G. X belongs to G. Okay, implies that okay X H X inverse 1 X H X inverse 1 belongs to H. Okay, belongs to H. Okay, that is IT means that is okay X belongs to XH X inverse on XH X inverse on subset H. Okay, and for every X belongs to G, for every X belongs to H. Okay, the condition states that is normal in G if and only if the conjugations of an element of H by an element of G belongs to H. Okay, G belongs to H. Okay, and next proof. Let H be a normal subgroup of G. Then AH is equal to HA. Okay, AH is equal to HA. Okay, and for all A belongs to G. A belongs to A belongs to G. Okay, let X belongs to G. X belongs to X belongs to G, and H belongs to small h belongs to capital H. Okay, and then XH XH okay belongs to AX. Okay, XH belongs to AX and X belongs to G, H belongs to H. Then XH belongs to AX as AX is equal to HX and XH is equal to H1X. Okay, H1X for some H1 for some H1 belongs to capital H. H1 belongs to capital H. So XH X inverse 1 is equal to H1 belongs to H. H1 belongs to capital H. Okay, H1 capital H से belong करेगा. Okay. Next, conversely, let the conditions hold that X belongs to G. Okay, let P belongs to XH, then P is equal to XH2, then P is equal to XH2 for some okay for some okay for some H2 belongs to H. H2 belongs to capital H. Okay. Next is equal to XH2 X inverse 1 XH2 X inverse 1 okay into X. Okay, and X H3X since X H2 X inverse 1 X H2 X inverse 1 is equal to H3 for some okay some for some okay H3 belongs to H okay H3 क्या करेगा H में belong करेगा. Next, does P belongs to XH. Okay, P belongs to XH. P belongs to XH. Okay, and next P belongs to क्या करेगा capital H x से बिलोंग करेगा एंड देयरफॉर ओके x capital H subset hx hx. Okay, this is one equation. Okay, and let q belongs to let q belongs to h capital H a. Okay, q belongs to capital H a, and then okay, and then q is equal to h4 q is equal to h4x. Okay, for some h4x. Okay, for some okay, for some h4 belongs to capital H. H4 belongs to capital H. Okay, and is equal to x x inverse 1 h4x. Okay, is equal to x x inverse 1 x inverse 1 h4. Okay, x inverse 1 to the power minus 1. Okay, next is equal to x x y. Okay, h4 y inverse 1 y inverse 1. Okay, where where y is equal to क्या होगा x इनवर्स 1 कौन से किस एलिमेंट से बिलोंग करेगा g. ओके g y is equal to x inverse 1 belongs to g. Okay, and next is equal to x h5. Okay, this is h5, and since y h4 y inverse 1 y inverse 1 is equal to h5 is equal to h5. Okay, and for for some for some h5 belongs to h for some h5 belongs to h. Okay, for some h5 belongs to h. Okay, thus okay thus okay, please note down thus okay thus q belongs to hx. Okay, q belongs to hx. Okay, implies that q belongs to xh. q belongs to xh. Okay, q belongs to xh, and therefore hx and therefore hx subset xh. Okay, that is equation number 2. Okay, equation number 2. Next from 1 and 2 xh is equal to hx. Okay, and next and this holds for every x belongs to h, x belongs to g. Okay, and and this holds for every x belongs to g. Therefore h is normal. Okay, therefore h is normal in g, normal, normal in capital G. This is proved. Okay, next, first you note down this topic. This topic is very most important. Okay, note this topic. If H be a if H be a non-empty H be a non-empty okay a non-empty subset. Okay, if H be a non-empty subset okay of G of of G such that such that non-empty subset, okay, such that x h x inverse on x h x inverse on subset capital H. Okay, and for all, okay, this is for all symbol. X belongs to G. X belongs to capital G. Okay, then then okay, then H, then H, okay, then H may not be, may not be, then H may not be a normal, may not be a normal, okay, subgroup of G, normal subgroup, sub, normal subgroup of G, okay, normal subgroup of G, okay. For example, I repeat this topic: if H be a normal empty subset of G such that X H X inverse subset H for all X belongs to G, then H may not be a normal subgroup of G. Some example, okay, let G is equal to Z, okay, positive additions and H be a and H be the and H be the set of and H be the set of set of okay set of all odd integer integers odd integers, okay, then for every, okay, then for every then for every okay then for every X belongs to G, X belongs to capital G, okay, and H belongs to capital H, okay, and X H inverse 1 is equal to H belongs to capital H, okay, but H is not, but H is but H is not, okay, but H is not even of, but H is not even of a subgroup of G, even of a subgroup of G, subgroup of G, of G, okay. For example, G is equal to Z positive and H be the set of all odd integer, then for every X belongs to G and H belongs to capital H, and H X inverse is equal to H belongs to H, but, but okay, but H is not even of a subgroup of G, okay. So thank you, take care, goodbye.